Hey, y'all. Okay, let's keep going with Unit 10, okay, and circles. But guys, today we're going to talk about the angles inside of a circle and the arcs that they create. Now, what does that mean, Miss Smith? Okay, so let's take a look. We're specifically going to talk about a central angle and an inscribed angle and what those are. But first, let's talk about what is an arc. Hey guys, an arc is part of the circumference of a circle. Okay, so an intercepted arc, okay, and I'm going to highlight some things here. An intercepted arc is an arc that is created by two lines, two rays, or two segments. Okay, so let's kind of regress here for just a second. So an arc is part of a circle. Well, guys, isn't your protractor part of a circle? Because if you put two of these together, wouldn't they make a full circle? Yes. Okay. And a full circle is 360 degrees. Your protractor is half of a circle. So wait a minute, that's how many degrees? Half of a circle? Yeah, 360 divided by 2, 180. Your protractor is 180 degrees. Now, what we're going to look at is that our arcs are going to be measured in degrees. But when we talk about an intercepted arc, we're talking about maybe just this part right here, okay? Well, how do we figure out that measurement? We're going to use the angles in the circle that create it. So let's take a look. So if you guys look right here, okay, a central angle, that's the one that I highlighted in red. The vertex is in the center of the circle. Hey guys, doesn't that make sense? Central angle, center of the circle, right? So do you see how this angle creates arc ST? Okay, so how does that help us with the measurements? I'm going to show you guys here in just a second. But first, I want to talk to you guys about what is an inscribed angle. An inscribed angle is an angle whose vertex is on the circle. Now, ladies and gents, when I say on the circle, that means on the circumference. Okay, that means on the edge. If we say in the circle, that just means somewhere inside the circle. Okay, so on the circle means on the circumference. Okay, so you guys see that we have two angles here that create these arcs. Okay, well, how does that help us find the measurements? Well, guys, the arcs and the angles have a relationship. Their measurements have a relationship. Okay, the central angle. The relationship between the central angle and the arc, they are the same. So if you guys will notice right here, this central angle is 82 degrees. So that means that this arc also opens up 82 degrees. But the inscribed angle right here, the measurement between it and the inscribed angle, the arc is twice the measure of the inscribed angle. Now, that's because what we're doing is we're taking that vertex and we're pulling it away from the center of the circle. So that means that the angle's going to get smaller as the arc gets bigger. Okay? All right, so how do we denote an arc? All right, so guys, right here, and you guys will see this. Okay, this right here represents an arc symbol. It's literally an arc over the names of the two arcs, or the 2 points that create that arc. So the expression MST with the arc symbol is read as the measure of arc ST. And when I say ST, I go from S to T right here. The measurement of arc ST. Okay, well wait, Miss Smith, how do we know that you're not talking about going this way from S all the way around to T? Here's how you know. Okay, and you guys might want to write this down, okay? So the reason why, when I say arc ST, and let me get this going here the right way, when I say arc ST, guys, that is an arc named with 2 letters. That means that it has to be less than 180 degrees. When an arc is greater than 180 degrees, or equal to 180 degrees, we have to name it using 3 letters so that it tells us which direction to go around the circle. So, okay, I would name this arc SRT right here, and that means that it is greater than or equal to 180 degrees. So again, when we name an arc with 2 letters, It's what we call a minor arc. It's less than 180 degrees. And when we name it with 3 letters, that means it's a major arc. It's greater than 180 degrees. So that also tells you which direction to go around the circle. Okay, so just a second ago, I actually talked to you guys about a semicircle. Okay, now, guys, you always will know it's a semicircle if it is created by the diameter. Notice that the diameter has to go through the center of the circle. Now, I want to talk to you guys about adjacent arcs. Remember, adjacent means next to. Okay, and you guys know how we could use part plus part equals the whole with line segments. We could do it with angles. Oh my gosh, we could do it with so many things. Guess what? We can do it with arcs too. We can say that this arc right here, okay, 105, plus this arc right here, which is 62, equals the whole entire thing, right? Part plus part equals the whole. Okay, so we're going to be using this here in just a second when we go to solve for some measurements. Now, before I do that, guys, I want to talk to you guys about a little bit more vocabulary. Okay, we are going to look at what's called an inscribed polygon. Inscribed means that it is inside of a circle. But what is special about an inscribed polygon is that every single vertex, all of the vertices, touch the circle. Okay, they are on the outside of the circle. And then we have what's called a circumscribed circle. Well, that's the circle that's outside all of the vertices. Okay, so you can also have an inscribed circle and a circumscribed polygon. That would look something like this. Okay, so if the circle is inside, okay, and then we have what we call a circumscribed polygon, that would look like something like this, where all of the sides of the circle, and that's not a very good drawing, but you guys get what I'm talking about. Okay, do you guys remember tangent lines, right? So the circle would touch the polygon at exactly 1 point. Okay, so it can go either way. The circle does not have to be on the outside. The circle can also be on the inside. Okay, all right, now we also have what's called an inscribed right triangle. Okay, so guys, if you have a right triangle that is, okay, created right here by the hypotenuse is the diameter, then what is always, always, always true is that the arc that it creates is 180 degrees. Okay, so I'm gonna backtrack for just a second. Okay, so let's see, does this make sense? Hey guys, look, this angle is on the circle. Okay, it comes out and it creates this arc, doesn't it? Okay, do you guys remember I said an inscribed angle has an angle relationship or measurement with a relationship with the angle. My gosh, guys, I seriously need chocolate today. I think I'm going to make some cookies this afternoon. That sounds good, doesn't it, guys? Okay, so let me backtrack again. We said that the inscribed angle has a relationship with that intercepted arc. Okay, so right here, this arc is 180 degrees. So that means that the inscribed angle has to be half of that, which means it has to be 90 degrees. Okay, so you guys don't even have to use the inscribed circle if you know that the right triangle, or a triangle in general, any triangle, when the hypotenuse is the diameter, it has to be a right triangle. Okay, all right, next, guys, I am going to work out some problems with you, and we're going to start with question number 2. So let's go down and take a look at question number 2 together. Okay, now, question number 2. This looks a little bit different. This doesn't have any angle measures. It doesn't have any arc measures. It has percentages. Miss Smith, what are you doing? Let me show you. You guys have seen circle graphs before, pie charts, as we normally call them, okay? This is a visual representation of what is in your algebra review. So how do we work this out? Well, to find the measurement of arc VW, and I'm going to highlight that. Arc VW is out here. To find that arc measure, I need to find out, well, what percentage of the circle is, okay, this central angle right here. Okay, so what we're going to do is we're going to compare. We are going to compare the arc measure or the angle measure to the percentage. So when I say compare, okay, so that looks something like this. We've got an angle and we're going to compare it to the percentage. And I'm going to ask you guys to do this. P over W. That means part over whole. Okay, so part of the angle measurement. We don't know that, do we? Or we don't know, this also would be X because we don't know that arc measure. Okay, we don't know that. So that is our unknown variable. The whole angle measure. So guys, in a circle, the whole angle measure is how many degrees? Yeah, I talked about it earlier. The whole angle measure of a circle is 360 degrees. Okay, so we have the part over the whole. Okay, now, let's see. Part of the percentage. Part of the percentage that we have is 31%. Okay, if I were to add up all of these percentages, they should all add up. The whole thing should be 100%. Okay, now, guys, you've seen problems like this before. You can cross multiply and divide, and you can find out what the measurement of that arc is. So here's what I want you guys to do. Rounded to the nearest tenth, I want you guys to tell me, what is the measurement of arc VW? How'd you guys do? Cross multiply and divide. You should get 111.6 degrees. And guys, do not forget your units. Your units are degrees. Our arcs and angles are measured in degrees. Okay, so do not forget your units. Okay, so now that I've kind of shown you guys how to set this up, okay, you guys can work out the rest of this problem and your algebra review. Now, guys, let's go take a look. Let's go down to number 6 next. I'm going to work out number 6. All right, so down here at number 6, guys, we're going to read the given information. That is important information right there. It says that line segment PR and line segment SQ are diameters of the circle. Oh, so if SQ is a diameter, then that means that this part of the circle that I just highlighted in green has to equal 180 degrees, doesn't it? Oh, but I can't find the value of X or Y because if I were to add those up, if I were to do part plus part equals the whole, well, that would give me an X and a Y in the same. I can't do that. So guys, let me talk about what we can do. Okay, so when you look at this, let's go back to what we know. We know that right here, we've got a central angle, don't we? That central angle is congruent to the arc. So that means that this arc right here is congruent to that angle. But do you guys see that we have vertical angles right here? Oh, and vertical angles always have to be congruent. So that means if those two angles are congruent, that means that these two arcs are also congruent. Okay, so if the two arcs are congruent, then, hey guys, do you guys remember how we set up when we have congruent parts, how we set that up and how we solve for it? All right, come on, I'm sure you remember. I want you guys to go and set this up and solve for X, knowing that those two arcs are congruent to each other. How did you guys do? Okay, so you should have gotten that X is 10 because if those two arcs are congruent, then I can set them equal to each other. And when you go through and you solve, you get that X is 10. Okay, but great, Miss Smith, how does that help us to find Y? Well, guys, do you remember what I just talked about a second ago? I said that because SQ right here is a diameter, then I know that these two arcs right here have to equal 180 degrees. Okay, so what does that look like? Guys, here's what that looks like. First of all, we know what X is, don't we? So let's plug in X and find the measurement of arc PS. So 9 times 10 is 90, minus 9 is 81. So this arc right here is 81 degrees. Okay, and guys, I just said it just a second ago, these two arcs right here add up to 180 degrees because SQ is a diameter. So that looks like this, 81 plus 10y minus 1 has to equal 180. Part plus part equals the whole. All right, guys, work your magic. What do you get for Y? How'd you guys do? Yes, it's also 10. X and Y both equal 10. Okay, so take a look at my work now. Hey guys, what we just did there, part plus part equals the whole, and our whole in this case was 180. Okay, so now we know what Y is. So we can go and plug it in. Okay, so 10 times 10, hey guys, that's 100, minus 1 is 99. Okay, but how does that help us get closer to what we need? It's asking us for the measurement of arc SR. That is the next thing it's asking us to find. Well, hey guys, there's a couple ways we can do this. You can use what you know about vertical angles. You can also use what you know about the diameter in a circle. You can also use what you know about all the arcs in a circle and what they add up to. Okay, so there's a couple different ways that you guys can figure this out. And I want you guys to take a guess. What do you think might be the measurement of arc SR? Okay, let's see if what you were thinking was on track. So if you guys noticed in my picture right here, and I'm going to zoom in my picture right here, I marked that we have vertical angles that are congruent. That means that the arcs are also congruent, which means that SR, arc SR, and arc PQ are marked congruent. So that means that PQ has to also be 99 degrees. And yes, Miss Smith, you forgot your degree symbol on all your arcs. There we go. Okay, now what would be my work? Okay, I could say that arc PQ has to be congruent to arc SR. Okay, I could say that. Okay, I could also plug in and say that 10 times 10 minus 1, I plug in my Y, equals 99. That's what my work could look like. Okay? Now, do you guys see how we're thinking logically about what we know in a circle? What's really great is that we know that the angles always add up to 360. Okay? The arcs are always going to add up to 360. Okay? That will help us out. Now, guys, I'm going to work out one more with you. I'm going to go down to number 12 with you guys and work that one out. Now, this one's a little bit different. Let's go take a look. Okay, now on this one, guys, all it's asking us to do is find the measurement of arc RS. Okay, so I'm going to highlight that, and what we're going to do is that is our unknown variable, isn't it? RS, right here. So I'm actually going to say that's my X. That's what I need to find. Okay, now, guys, let's look at what we have. We have an angle measure of 82 degrees. We have an arc measure of 167 degrees. All right, so knowing what you know about what type of angle this is right here, okay, S is on the circle. So that means that that is an inscribed angle. Okay, so then what would the arc measure of RT be? Okay, so I'm asking you right now, what would this measurement of the blue arc, what would that be if we have an inscribed angle? Okay, so guys, remember we said that an inscribed angle and the arc that it's created, okay, so this would be 82 times 2 because the arc measure is twice the measurement of the angle. Okay, so 82 times 2, this arc measure right here is 164 degrees. Okay, well, let's look at what we have. Well, what we know that, and I'm going to point to it right here. We know that we're looking for this. We have this arc measure is 164. This arc measure is 167. Oh, hey guys, what do you know about all of the arcs all around a circle? What do they add up to? 360. Oh, okay, so you guys work it out. They all add up to 360. Go work this out and tell me, what do you get for the measurement of arc RS? Were you on the right track? Okay, so part plus part plus part equals the whole. They all add up to 360. So you should have gotten that X is 29, which means that the measurement of arc RS is also 29 degrees, isn't it? Degrees. Did you remember the degrees? Okay, you got to remember when we ask for your units on this, okay, when you're dealing with an arc or you're dealing with an angle in this unit, okay, the angles are in degrees, the arcs are in degrees. Okay, so guys, what we've done today, we have taken some central angles, some inscribed angles. We've looked at, oh my gosh, arc measures and part plus part equals the whole. Okay, so you're going to finish the rest of this assignment, okay, in class and ask questions. And until next time, adios.